In this video, I am going to do a speed comparison between the Raspberry Pi Pico and the ESP32 S2 board, two of the most powerful and inexpensive boards for makers. Before running the computation speed benchmark I have developed, let's take a quick look at the most basic specs of each board to get a sense of what to expect. The Raspberry Pi Pico board features two 32-bit Arm Cortex M0 Plus cores operating at 133 MHz. It also offers 264 KB of RAM memory and 2 MB of flash memory, and it costs, at the time of this recording, around $7. The Lilygo ESP32 S2 board, on the other hand, features a single-core 32-bit LX7 microcontroller operating at 240 MHz. It also offers 320 KB of RAM memory and 4 MB of flash memory. Its price today is around $8. So, based on the specifications, we can conclude that the ESP32 S2 is faster than the Raspberry Pi Pico in single-core workloads. How much faster is the question? We can't know without running a benchmark because the boards employ processors with different architectures. Based on the operating frequencies of each board, we can estimate that the ESP32 S2 single-core performance will be roughly 80% faster than the Raspberry Pi Pico's single-core performance. Is this correct? I wanted to find out. So I created a simple but computationally intensive test that could run on both boards. Both boards will execute the same CircuitPython application, which will display a splash screen for 2 seconds before starting to calculate the pi for 1500 iteration of a pi approximation algorithm. Both boards will show the results on a 1.8-inch color TFT display. Which board will complete the task the fastest? Let's find out. I am going to power up the boards at the same time using this power bank. As you can see, the ESP32 S2 board performed the computation in approximately 3.13 seconds, whereas the Raspberry Pi Pico required 6.48 seconds. The boot-up time of the Raspberry Pi Pico is slightly shorter, but this time is not counted in the benchmark, only the Pi's calculation is counted. In single-core applications, the ESP32 S2 board outperforms the Raspberry Pi Pico board. It is approximately 107% faster. Percentages can be deceiving about how quick something is, so let's run the benchmark again, but this time I'll remove the boot-up timing difference for better comparisons. The ESP32 S2 is twice as fast as the Raspberry Pi Pico, and the difference is noticeable and important. Let's now measure the power consumption of each board while running the benchmark. The Raspberry Pi Pico and the display needs around 45 mA of current while running the script, while the ESP32 S2 and the display needs around 77 mA of current. The display needs around 20 mA, so we have around 25 mA of current for the Raspberry Pi Pico and 57 mA of current for the ESP32 S2. So the ESP32 S2 needs around 128% more current to run the script, but for 107% less time. In total, the Raspberry Pi Pico needed 10% less power to perform this task, which in my opinion is not significant. If you are interested in the script, I will include a link to it in the video description, so you may do your own testing. If you need more information on connecting this display to both boards, I'll link to the thorough videos I made about it here. To summarize, the ESP32 S2 outperforms the Raspberry Pi Pico in single-core processing workloads. It costs roughly the same, it is $1 more expensive, it has more RAM, more flash memory, and of course it offers Wi-Fi, which the Raspberry Pi Pico lacks. The Raspberry Pi Pico, on the other hand, has 2 processing cores, but I believe that in more than 90% of our projects the use of a second core is unnecessary. The Raspberry Pi Pico has a significant edge in terms of popularity and excellent documentation, which makes development considerably easier. So, which board should you use? Whatever board best matches your requirements. If you need computing power, the ESP32 S2 is the fastest board available for less than $10. I would love to hear your thoughts on this comparison in the comment section below. Thank you for tuning in. I'll see you next time.